Assalamualaikum and hello to all of you. Before you watching this video, I would like to introduce myself and my other team members. I am Nuratasha Adila. And next is Nur Izzatul Nuha. Next is Willibrod Benedict. And next is Shafiz Shazwan. And then Luqman Al-Hakim. Next is Muhammad Firdaus. And the last one is Badr Amin.
I will proceed about the introduction of the company and then the tragedy background. So as we all know that the National Aeronautic of Space Administration, as also called as NASA, was started on October 1958 as a part of the United States government. So NASA is the charge of United States science and technology that has to do with airplanes or space. NASA was signed into a law on July 29 in 1958, which is the purpose to provide the research and into a problem of flight within and outside the Earth atmospheres and for other purposes. And then the act was signed, which was to overcome the inter-service rivalries that had confused the U.S. missile or United States missile and space program. However, the space shuttle's mission was cancelled after the Challenger disaster in 1986. The Challenger explosion disaster is the Challenger explosion that the explosion of the United States Space Shuttle Challenger shortly after its launch from Cape, Florida on January 28, 1986.
The Space Shuttle Challenger is scheduled to launch on January 28, 1986. When the crew boarded the orbiter Challenger that Tuesday morning, the sun had been up for less than an hour and the temperature was a few degrees above freezing. NASA gave the go-ahead to launch the shuttle. However, 73 seconds after the launch of the Challenger, the space shuttle is engulfed in flame and explodes, leaving only white vapor behind. The mission quickly turned into nightmare, and the image of the grotesque Y-shaped explosion dominated the news cycle for decades. In the month following the accident, the Rogers Commission, led by former Secretary of State, combed through every piece of data to determine the root cause of the disaster. What they discovered was a very different launch than the one people saw on television. A puff of black smoke could be seen coming from the bottom of the right solid rocket booster in the image of the shuttle on the launch pad. The smoke then vanished, only to be replaced by a flame 66 seconds later. According to the video, as the shuttle rose higher, the flame grew quickly and was forced toward the large orange fuel tank. Data confirmed that there was a leak in the booster, but no one could intervene because there was no way to stop it while it was firing. The leak was traced back to a tiny rubber part known as an O-ring, which served as a seal between the section of the rocket booster. The O-ring is extremely sensitive to a variety of factors, including the near freezing temperatures. The elasticity of the O-ring was lost when it was exposed to near freezing temperature. This prompted a more pressing question. If the O-ring was known to be temperature sensitive and could only function above 10 degrees Celsius, the temperature on the launch pad that morning was 2 degrees Celsius. What motivated NASA to launch it? That's all. Thank you.
I will cover the ethical issue. So the first point is professional responsibility. Design engineers are solely responsible for maintaining a flawless and professional design. Economic figure and varied increase in the cost to produce and purchase product. Resources need to finish the project that can prevent the design from becoming perfect and professional. The implementation window was quite narrow since NASA and the design team's project of alternating the O-ring design had the potential to prevent the Challenger shuttle from completing its scheduled mission. The project was not complete due to pressure of the time constraint. So the second is effective communication. One of the major contributing ethical factors to the Space Shuttle Challenger disaster was a lack of effective communication between the NASA engineer and management. Morton Telcol, that is the company that designed the solid rocket booster, and NASA management had inadequate communication as well. Following the event, Morton Telcol engineer Roger Boscioli alleged that the discussion leading up to the Challenger launch were packed with extreme customer intimidation. Clearly, this was not the conducive to fostering an environment in which everyone felt free to voice their view and make informed decisions. And the point number 3 is flight plan schedule versus safety concern. One of the ethical concerns we looking into part of this case study was NASA flight rate plan and the enormous pressure that NASA was under to improve their flight rate. Due to the reduction in people committed to specification launch date, NASA capacity to safely resolve any critical difficulty will be harmed. As a result, it put unnecessary pressure on NASA management team to rush decision on real issue that could cause shuttle launch to be delayed. The management team appeared to be acting as though sticking to the schedule was more important than the astronaut safety due to the straight flight plane timeline. So that was for me. Thank you.
Next is apparent unsafe launch condition. There was a major lapse in communication between NASA and Morton Thiokol engineers and the managers in the position to make decisions. Although some engineers felt that the extremely cool temperature on the day of the shuttle launch could pose major problems, so some engineers believed that the O-rings would still function properly. This inability to come to a consensus in what ultimately led to the launch of the shuttle. So next is NASA reliance on emergency safety control. In the actual event of the Challenger shuttle disaster, an issue with a leak in the O-ring seals on the SRB unit was ultimately blamed for the loss of shuttle and crew. Interestingly enough, the design engineer were already aware of the issue with O-ring sealing problems from the inspection of previously used SRB unit. However, the situation was not deemed critical since there was a secondary O-ring which was originally designed as a backup safety control measure in the event of the primary seal failure. Acknowledging a problem with the main seal and relying on the emergency safety control of the second seal to prevent a catastrophic failure does not seem very ethical in my opinion.
The first factor of the accident is happened from a social factor, which is both NASA and its contractor Morton Thiokol failed to effectively respond to the danger posed by the defective joint design. Second is poor in decision making process that led to the launch of Challenger, and the third is lack of communication. The decision to launch 51L was made on the basis of inadequate and occasionally incomplete information. Edward Tuffle, which is graphic designer, he says that if Morton Thiokol engineer had communicated their result on the relationship between cold temperature and burning plug in solid rocket booster joint more clearly, NASA manager would have been persuaded to abort the launch. Roger Boinjoli, one of the engineers in Morton Thiokol, he had informed his supervisor about the defect cold weather on the sealant, but his supervisor ignored him. After the incident happened, he left Morton Thiokol and became an ethic speaker. He claimed that the Morton Thiokol manager caucus, which resulted in a proposal to launch, constitute the unethical decision making from coming extreme customer intimidation. The second factor of this accident, we can say it from business factor. Richard Feynman, theoretical physics, he by immersing a sample of the material in ice weather, he illustrated how the sealant become less resilient and susceptible to seal failure at an ice cold temperature. He was so critical of NASA safety culture that he threatened to remove his name from the report unless it include his personal observation on the shuttle reliability.
The safety lesson one can learn in the Challenger case involve many risky situations, which are as follows. So the first one is like negligence in the design aspects. The booster rocket casing recovered from the early flights indicated the failure of field joint seal. So no design changes were incorporated. Instead of 2 O-rings, 3 rings should have been fixed, but there was no time for testing with the 3 rings. At least 3 rings could have been tried while launching. And the next one is the test on O-rings. Tests on O-rings should have been conducted down to the expected ambient temperature, like for example to 20 degrees Fahrenheit. No normalization of deviances should have been allowed.
Alright, so thank you to all my group members. My name is Sharif Azwan and I'm going to conclude about the project or the research that we have done so far after describing the facts in NASA stories and considering the fact in the Challenger disaster of case study. Okay, so regarding that, we need to understand that the main problem that occurs in the NASA story is that the lack of communication between the manager and between the poor safety culture. So from that, we need to understand that they not implement the engineering ethics principle in the organization. So that's why, and we as an engineer, we need to outline the ethical principles that govern decision and behavior at a company or organization, as I said before. So what is the benefit if we conduct the outline? It will shows how employees should behave, and as well as the specific guidelines and for handling issue like harassment, safety, and conflict of interest, to be precise. So let's discuss about the problem in this study. First, engineer violate their duty to put public safety above concern about the maintaining launch schedule. And next, what are the characteristics that determine whether or not the public perceive an engineering decision involve ethical violation? So as we know, what is the importance of if we study engineering ethics and we implement in the organization? What is the importance is it is crucial to understand the standards governing and what is acceptable behavior in the practice of engineering. And next, it is important to practice engineering ethically, because if you do not implement that, it will cause to the personal injury, property damage, disciplinary action, impact on the reputation of the employer, client, profession, and possible of loss of job or business. Okay. So from that, we know that engineers should accept personal responsibility their professional activities provided. However, engineers may seek identification for service arising out of their practice other than gross negligence, where the engineer interests can otherwise be protected. So this is true. So we need to practice all of this. First, we need to understand about the fundamental canons, and next we need to understand about rules of practice, what an engineer must do, how to deal with the client, agent, and how to relate the engineering ethics, the ethics in the engineering. Okay. And then professional obligation, of course. And next we need to have executive committee. So what I can conclude here, a code of ethics and professional conduct outlines the critical principle that govern decision and behavior at a company of organization. So they will give the specific guideline to all the employee in order to avoid from the problem that I have stated, and to all my group members that has been stated all the problem, and we need to know how to handle the issues and give them the specific guidance in order to avoid a conflict of interest. I think that's all from us. Thank you so much.